The second day of 12.1 covers inverse trig functions. As a refresher, here are 6 trig functions. We have the SOHCAHTOA ratios that you learned in back in geometry, and then we have the 3 new ratios, cosecant, secant, and cotangent, which are just the flip of our original 3 functions. When it comes to solving for a missing side, we want to use one of those ratios. Here we have a 30-degree angle, we have the adjacent side, and the hypotenuse, which means we're going to use cosine, plug in everything we know, and then once we know that, we can just multiply by 10 times the cosine of 30 degrees, which gives us 8.66. However, not all trig problems are the same. In this one, for example, we're looking for an angle measure instead of a missing side. We're going to start off the same way. We have the opposite side and the adjacent side, which makes this a tangent problem. And we're going to plug in everything we know. Now the difference is normally we'd have a variable over here. This time the missing variable is the angle. The tangent of some angle equals 3/5. And in order to solve this problem, we need to get rid of tangent, so the x is all by itself. And the way we do that is with a function called the inverse tangent. You'll see it in your calculator as tan with a -1 on the top, or sometimes it's called the arctangent, A-R-C-T-A-N. So an inverse tan and a tangent are opposites of each other. They cancel out, leaving just the x. And then on the other side, we're going to do the inverse tangent of 3/5. That's what we're going to key into our calculator. As a note, when we use the word inverse here, we're not talking about it in the sense that we traditionally talk about inverses in math class. So for example, the inverse of 3/4 is 4/3. Inverse meaning the fraction flipped. Okay, here we have the inverse tangent. So don't confuse that with the cotangent, which is really just the tangent flipped. Instead, we're looking for this actual function in the calculator. Now you can ignore this on the screen here. I couldn't find an image with the actual functions listed there. But if we go into the place where we find all the other trig functions. So on the TI-34, it's right above that pi sign. We click second, we click pi, you'll see sine, cosine, tangent, and then if you scroll down a bit, you'll see these 3 options: inverse sine, inverse cosine, inverse tangent, also sometimes referred to as arcsine, arccosine, arctangent. So we're just going to take this function here, and then we're going to use it to find the inverse tangent of 3/5, and we end up with 36.9 degrees as that missing angle. Let's do another one. So here we have a missing angle again. It's the x. Anytime we have a missing angle, we have to solve it using an inverse trig function. If we're missing a side, we just use the regular SOHCAHTOA or the 3 new ones, secant, cosecant, tangent. So we set it up. This is an adjacent side and the hypotenuse. Plug in everything, and we see that the cosine of some angle equals this ratio, 15/17. We want to get rid of this cosine, so we go into our calculator. We're looking for inverse cosine because an inverse cosine and a cosine would cancel out, leaving x equals inverse cosine of 15/17, and that'll give us 28.1 degrees as our answer. Lastly, in a throwback to geometry, we have special right triangles, namely a 45-45-90 triangle and a 30-60-90 triangle. In a 45-45-90 triangle, we have 2 sides that are the same length because they're opposite angles that are equal to each other. So our leg lengths we'll call x. The hypotenuse is just going to be that value times radical 2. In a 30-60-90 triangle, across from our smaller angle, we'll call that side x. Hypotenuse is just double that smaller leg length, and then the longer leg is that smaller leg length times radical 3. If we know something's a 45-45-90 triangle or a 30-60-90 triangle, we can fill in all 3 sides as long as we know one of them. And along with that, the sine, cosine, tangent stays the same regardless of the triangle. So the sine of 30 degrees is always the same thing, for example. And we can use these special right triangles to figure this out. So for example, sine of 30 degrees is the opposite side over the hypotenuse. So it would be x over 2x. X's would cancel out, and we'd be left with 1/2. The sine of 30 degrees is always 1/2, regardless of what the side lengths are. So we can see that here in the table. And this table is filled in based on those special right triangles. Even if you don't have a calculator, this can help you figure out these common angles. And as you get farther into pre-calc or calculus, this will be required knowledge. So when we look at this table, there's a pattern to it. So let's start off by looking at the sine here. So this is just increasing by radicals over 2. So radical 0 over 2, this equals 0. Radical 1 over 2 equals 1/2. This we can't simplify, so it's just going to stay as radical 2 over 2. Radical 3 over 2, and then radical 4 over 2 would equal 2 over 2, which is 1. So as we go through those special angles, we can follow that pattern to fill out this table. The cosine is that same exact thing, it's just flipped around. It starts on that side. Tangent is the sine divided by the cosine. So for example, 0 over 1 is 0. Okay, if we look at 60 degrees, radical 3 divided by 1/2, keep it, switch it, flip it. 2's would cancel out, and we'd be left with radical 3. Okay, so in all of these, it's just the sine divided by the cosine. So to use this in an example, let's go back to the first problem we did in this lesson. So we had a missing side, x on the bottom here. It's adjacent to this angle of 30 degrees, and we know the hypotenuse, so it's a cosine problem. Fill in everything we know, and we end up just doing 10 times the cosine of 30, x equals 8.66. So here we have one of those special angles. It's 30 degrees. We're looking for the cosine of it. So let's do the same problem with this table. We have a 30-degree angle. We want the cosine of it. We know that this side, the hypotenuse, was 10, which means the shorter leg is just going to be half that. That would be 5. And then this one would be 5 radical 3. Okay, if we took that and we put into a fraction, adjacent over hypotenuse, we'd have 5 radical 3 over 10. And then these guys would simplify. 1/2. Radical 3 over 2. If you know this table, which will eventually you'll need to know for later stages of pre-calc or calculus, knowing that, you can just jump right to the answer and skip the math. If we're asked instead to find something like the sine of 30 degrees, okay, it would just be opposite over hypotenuse, 5 over 10. It's always 1/2. Okay, and we can use this for any element in the table. Tangent of 45 degrees, sine over cosine equals 1.